Hey you guys, today we're working on our last conic section and it is the parabola. We have done this a little bit before already. We did it a while ago though. So we're going to revisit it and just make sure that we all have it down so that when we move on to pre-calculus next year, we are good to go. So remember, the parabola is formed by cutting diagonally through a cone. You guys have spent a lot of time working on your conic art. And so this should be familiar to all of us. So let's see, let's go ahead and draw the way it should look here. Back like that. So we get a parabola right in this area. All right, so hopefully you guys can all see that. Okay, so now if we were to take that and graph it on a graph, it would look something like this. And so this point up here corresponds with this one. That is the vertex. Let's go ahead and put a couple of key terms on here. That is the vertex. And these 2 points right here and here, they have a few different terms. They're either called the x-intercepts, they're called the roots sometimes, and sometimes they're called zeros. All 3 of those terms mean the same thing. Or when you're given a quadratic equation and asked to solve it, that's what you're solving for, is the x-intercepts or the roots or the zeros. Okay, so that's again x-intercepts, roots, and zeros. So what we're going to look at is we're going to look at different forms of equations for parabolas and then look at graphing them and finding each of these things, the vertex, the x-intercepts or roots or zeros. So we have a couple of different forms for equations of parabolas. And we're going to look at both of them. You need to be familiar with both of them. One of them is written in, so they have different terminology. Some math teachers and some books and some literature says one thing, and other books and other professors and other pieces of literature say different things. I'm going to stay with what we have been using in our conic section unit, which is standard form for the one where we have h and k. So we have looked at with ellipses and hyperbolas and circles that the center is at hk. To keep consistent with that, we're going to call this one standard form. So it looks like this: f of x equals a times x minus h squared plus k. And f of x and y, they mean the same thing. So it also could look like this: y equals a times x minus h plus squared plus k. And then we also have vertex form, which again, I know that some books and some math teachers or professors and everybody kind of has their own way of denoting these, but there are a couple different forms and then we're looking at both of them. So this one is ax squared plus bx plus c, or again, y equals ax squared plus bx plus c. Okay, so in standard form, let's make sure we move this up so you guys can see it. In standard form, the key pieces of information that we need for each parabola or each quadratic equation is we got the vertex, we need the axis of symmetry, the x-intercepts or zeros or roots, and then we also want to be really familiar with graphing them. So if we start with the axis of symmetry on this one, the axis of symmetry is at x equals h. It's that equation. Okay, so we take whatever h is, oops, my pen is dying here, and x equals h. So think of whatever's inside the parentheses, change the sign of h, and x equals the opposite sign of h, and that's your axis of symmetry equation. Okay, so for the vertex, again, make sure you guys can see this here. For the vertex, in this case, the vertex is at h comma k. So again, we have gotten really used to seeing that with ellipses and circles and hyperbolas. The center of each of those different conic sections was at hk, but we don't have a center here, we just have a vertex. And that's the place where it changes inflection. So axis of symmetry. Now, the x-intercepts and roots, so x-intercepts, roots, or zeros, the way that we find these, the way that we learned how to find these in class, there are a bunch of different ways. So diamond is one of them. I know we all have very different ideas about what the best way of teaching that is or learning that. I happen to think that the diamond is one of the easier ones. We learned completing the square. So completing the square. We've learned the quadratic formula. And in this, the one that works the best in this particular case is we already have the x squared isolated. If you see the x squared is isolated in the parentheses, so that would be the best method for something like this. So let's isolate the x squared. Okay, let me actually circle that, because if it's already in this format, there's no need to go back and try any of these other ones. Isolating x squared is going to be the easiest thing, and we're going to go through an example to show exactly what that means in just a little bit. Okay, let's switch over to the other form, which we're going to call vertex form. Okay, so the axis of symmetry in this one is x equals negative b over 2a. Okay, so we use this coefficient in for the top and then a on the bottom, or 2a. All right, then to find the vertex, we already found the x-coordinate of the vertex when we found the axis of symmetry. So let's go back here. I actually didn't put the axis of symmetry on our graph. And the axis of symmetry is the line that goes right through the vertex. So if symmetrical objects they have a line in which you fold the shape over onto itself on the other half, and it maps itself directly onto its side. So the axis of symmetry is that line. Okay, so that's this one, axis of symmetry. So if you notice, the axis of symmetry goes right through the vertex and in the x portion of it. Okay, so once we find the x-coordinate of the vertex here, we take that x-coordinate and plug it into the equation for y. Bx plus c, so we take this whole thing and plug it in anywhere there's an x, and then we have our vertex as x comma y based on what we found up here. Okay, x-intercepts or roots or zeros, same thing. Same thing as what we have in the other form. Make sure you guys can see that. Okay, but the difference with these two is that isolating x squared is not necessarily going to be the easiest thing. I always encourage you to try the diamond first. Some teachers teach it with guess and check or trial and error. Diamond, I think, is a really easy way of doing it. If that doesn't work, then you want to resort to one of these other, probably not the isolating x squared thing, because it's not going to be as easy in this one. But the others are really, really helpful. So, okay, everybody go ahead and switch over to the next video so we can do a couple of examples and you'll see how all of this works.